Alright, welcome back guys. So in this video here, we're going to do several example graphing. First couple example, we're going to graph using the slope-intercept form. If the equation we're given, if the lines of the equation we're given are in this form, we can identify the slope and the y-intercepts, and then we can graph using those two informations. Okay, so in this case, my m is going to be 2/3. My y-intercept, or my b, is, let's just do b. My b is 1, which is the y-intercept. Over here we have my m is -1/2, and then b is 2. Okay. So really this here is the y-intercept. And the y-intercept, the coordinates will be, always have a 0 for the x-coordinate, and then just going to be 1 for the y-intercept there. And over here, y-intercept is 0, 2. So how we're going to graph this is we're going to draw the xy axis, and we're going to start with the y-intercept 0, 1, so that's there, right? And then we're going to apply the slope. So the slope is 2/3, so that's going to be a positive slope. That's going to be rise over run slope there. So a rise is going to be 2, 1, 2. A run is going to be 3, 1, 2, 3. So we're looking at the second point there, and we're going to connect these two points to make a line. So I'm going to go ahead and do that. Okay, so that is a line. Okay, over here we have the slope is a -1/2. So the negative we can apply to either the numerator or denominator. So it's however you feel comfortable applying the negative to. But first let's draw our x-axis and a y-axis. Okay, let's start with the y-intercept 0, 2 is there. All right, so our slope is -1/2. So if you want to apply to, the negative to the numerator, so this becomes -1/2, or you can do 1/-2. So either one, it will work. Okay, so suppose I want to go with this here, -1/2. So that means my rise is -1. So instead of going up, we're gonna go downward since it's negative. So down 1 unit because the rise is negative, and then run's gonna be +2 units. So 1, 2. So it's going to be right here for the second point, and then we're going to connect these 2 points to make a line. Okay, and yep, there it is. So there's my lines. All right. Okay, so that's graphing linear equation or linear function using slope-intercept form if it's already in slope-intercept form. Okay, now the next thing is we're going to graph by using x and y intercepts. So I'm going to take a minute to kind of review x and y intercept a little bit. So x intercept and y intercept. Okay. So suppose we have a graph. Okay. Excuse me, a line. So I suppose this is a line. Okay. So the 2 points where the line crosses the x and the y axis. So this is the point where the line crosses the y-axis, and this is the point where the line crosses the x-axis. So those are the 2 intersection points. So the x-intercept is the point where the line crosses the x-axis. So at that point there, the y-coordinates is always going to be 0. There's no directions at all. There's no distance in the y-coordinates. However, in the x coordinates is whatever that that distance this would be. Right, so let's call that a. Okay, that distance a. So the x-intercept, this here is going to be a, 0, which is the x-intercept, just where the line intersect the x-axis. And let's call this vertical distance here, let's call that b. Okay, then that point for the y-intercept, this here, this point right there is the y-intercept. It's the point where the line intersect the y-axis. So we can say that point there will have the coordinate of, so there's no, in this point here, there's no unit distance on the x. X is going to be at 0. So 0, whatever the b coordinate is. Okay. So those are the 2 concepts we're going to use to graph lines much quicker if it's not in the slope-intercept form. So suppose we're looking at this problem here. Let me move this down. All right, actually let's go down further. start there. All right, let's look at the first one. So if this is the equation, okay, and we want to graph this using the x and y intercept, we can graph that by find the x and y intercept, plot those 2 points, and then draw the line. It's much easier in my opinion, because any line can be drawn using 2 points. Okay, so let's look at this one here. So example, 3x plus 2y equals 6. So notice that this equation here, this is in standard form. This form is called standard form. It's not in slope-intercept form. One way we can graph this is convert to slope-intercept form and graph it using this method we discussed. Or we can just graph it as in this form by finding the x and y intercept. Okay. So first we find the x-intercept. All right. So to find the x-intercept, notice that the x-intercept will have the y-coordinate always 0 by the definition. Okay. So we said set y equals 0 and solve for x. Okay. So let's go ahead and do that. So we have 3x plus 2 times 0 equal to 6. So our y-coordinate is going to be 0 if we want to find x-intercept. So that becomes 3x equal to 6. So x is 2. All right, so the x-intercept is going to be 2, 0. So this is the x-intercept. Okay, the x-intercepts always have the y-coordinate equals 0. All right, we're moving on to solve for y-intercept. Okay, so by definition, the y-intercept is this point there, which always had the x-coordinate always 0. So we're going to say, to find the y-intercept, we said x equals 0 and solve for y. Okay, so let's do that. So set x equals 0, solve for y. So we have 3 times 0 plus 2y equal to 6. So that means 2y equal to 6. That means y equal to 3. Okay, so now we say that the coordinates for the y-intercept is 0, 3. Which is the y-intercept. Okay. So there it is. These are the 2 points where the line crosses both x and y axis. So we're ready to draw the graph. So we said, here is the graph. Okay. So I'm going to do x-intercept is 2, 0. 2 on the x, 0 for y. So that's my point. And then 0, 3 for the y-intercept. So 1, 2, 3 for the point 0, 3. So this is 0, 3, 0, up. Let me just label so that way you see that this is 2, 0, and then 0, 3. And so now we're ready to draw the line. All right, there it is. Okay, so I'm gonna let you guys work on this one on your own here. There's one more thing I want to discuss is special lines. How do we graph special lines? And when I say special lines, I'm referring to the horizontal line and the vertical line, and how can we recognize the form or the equation when given in a certain equation. How can we tell whether it's horizontal versus vertical line? Okay. So we say how to graph vertical line and horizontal line. Okay, so for vertical lines, all right, so if I'm gonna draw a few example vertical lines here, so we got, all right, let's say 3 example here, right? So I say I have this vertical line, looks like that. Maybe this point here is 3, and then here's another vertical line here. Maybe this is -2, and then maybe this vertical line here passes through, let's say 3.4, for example. All right. So any points on these vertical lines, suppose if I want to pick any points here, right? So any points on this line, the y-coordinates, the x-coordinates is always 3 for any points on that line, and the y-coordinates kind of freely can be anything, right? It's arbitrary. So For vertical lines, the equation for this one is just going to be x equal to 3, meaning if it's written in this form, you know, if you're looking at lines with two variable x and y, this indicates the x coordinate is always 3, and the y can be anything. Okay. Similarly, since the vertical line passes through x equal to -2, our equation is x equal to -2. Over here, x equal to 3, 4. Okay, so that's vertical lines. Most likely, you're going to give it in this form here, and then you ask to graph the equation. Horizontal line is very similar. Okay. All right. So let's draw a few here. All right. Let's say we have a horizontal line passes through. This is, let's say that's 1, and down here, let's say that's -2, and then up here, let's say that's positive 3/5. Right, some decimal. Okay. All right. Okay. So again, if these are the horizontal lines, let's look at the first one. If I pick any point on this horizontal line, let's say I pick this point here, you gotta agree that the y coordinate of this point, the y coordinate, the y distance is always gonna be 1, right? So the x can be anything. So therefore, the equation of this horizontal line is gonna be y equal to 1. Indicate that the y coordinate is always 1. Okay, x can be anything. This is y equal to -2, y equal to 3.5, right? There it is. Okay, so for vertical line, it's going to be in the form of x equal to a constant. So I'm going to go ahead and jot that. So let's do red. So it's going to be x equal to some constant a. And down here, it's going to be y equal to some constant a. Okay, so those are two general form of vertical lines and horizontal line. Okay. All right, so in the next video, I'm going to talk about parallel lines and perpendicular lines and how are the slope relate to each other.